If you're going to design and build a system that can tolerate failure of some of its components, it's really helpful to understand what kind of failures can happen and also what kind of failures you're expecting to happen in your particular system and what kind of failures you're just like, that's too crazy, I'm never going to deal with that, I'll just, handle that one by hand. So, let's talk about some potential failure modes. For a fun exercise, I want you to pause this video right now and either write out a list or enumerate a list in your head of everything you could possibly think that might go wrong in your system. And then when you come back, I will go through my list. Welcome back. Here's my incomplete list of things that could possibly go wrong. One or more processes stops, or worse yet, it stops, then comes back up, and then stops again, and comes back up, in a crash loop. Data corruption. You get bad data appearing where you least expect it. You read something from disk and it's actually incorrect. Even worse, you read it from disk, it's incorrect, but it looks plausibly correct. You go to talk to a server or service that you depend on, and it's just not there. It's gone. One of your users has discovered a query of death. They're repeatedly sending you a query which causes your system to go down. You sent a query to a server or service that you depend on, and the answer it gave you back is wrong. Someone doesn't like you. They've set up a denial of service attack against your service, and your service is being crushed by the load. Even worse, lots of people really do like you, and they're sending you requests, perfectly valid requests, and you're still being crushed by the load, and you can't make your customers happy. For whatever reason, one of your servers went down. And the fact that that one server went down causes your next server to go down and so on in a cascading failure. So your system fails in production. But you can't get it to fail in testing, and you can't get it to fail in your debug environment. The system fails for a customer, but whenever you try it, you can't get it to fail. Uh-oh, you've lost some data. It's gone. Your system depends on the clock and the time of day, but for some reason it seems to have gone backwards. You've suffered a security breach. Your system, or at least some nodes in your system, appear to be owned. Fire, flood, earthquake, plague, air conditioning failure. Your system is going down. Even worse, your system has caused a fire, a flood, well, maybe not an earthquake, but it can definitely cause a power outage. One of your offices or data centers was raided by the police, and they've got your machines. Aren't operators powerful? Don't you wish you were root? Don't you love it when someone with root access makes a mistake and toasts your entire system? What about when someone with root access gets bored and automates away part of their job, and then that automation causes failure at a rate faster than any human possibly could break things? Cryptography is wonderful, except for when it isn't. If your certificates expire, what's your system going to do? You ran out of money or someone forgot to pay the bills. Now you don't have, take your pick, networking, power, data center floor space, computers. Your inbound stream of queries caused a small shift in the workload, and that resulted in a dramatic change in the performance of your system. Maybe it's too slow now. Better yet, maybe something's changed slightly in the performance of your workload, and now it went over a threshold and the behavior of your system is dramatically worse. Someone who you never realized was important left the company. And it turns out that the system critically depended on either their user existing or their workstation under their desk being up, and now the whole system commits suicide. You've deployed a binary to production, and it's working great, and you just want to add one tiny little feature. So you go to find the source code for it. Uh-oh. You don't have the exact source code for the revision of the binary that's running in production, and everything else you try doesn't actually behave correctly or perform correctly. Suddenly, you discover one of your nodes in your distributed system is behind a brand new government firewall. Your processes are running on kernels which are leaking memory, and they randomly crash. Your processes are running on a machine shared with other people's processes, and their performance is causing random perturbations in your processes' performance. You're running your computation over a very large amount of data. You discover that some of your data is corrupted, but the checksums still check out and say the data isn't corrupted. You found a hash collision. You've been using a library implementation of an algorithm you totally trust for years, and then all of a sudden you discover that what you thought was correct for all inputs isn't, and your algorithm is wrong. Now, the list above may sound kind of scary, and it's actually a list of things that I or close colleagues of mine have encountered in my work. And so, these are things that can actually happen, but a lot of them are very infrequent or things that have happened only once. And if something that only happens once is not worth automating away. Things that happen frequently are worth designing systems around making sure that they don't impact the reliability of the system. So, just to help calibrate my mental model of how frequently different types of failures happen, how about you in the comments below tell us the stories of things that you've seen go wrong?